Welcome back. Today we are going to talk about intervals, relations, and functions. The first interval we are talking about is the open interval. Let's say A and B are real numbers. And if we use round brackets with all A and B, this means an open interval. That means in the real numbers there's A and there's B. These are two real numbers. The open interval AB implies all the or includes all the real numbers in between A and B, but not equals to AB. So if we say X belongs to the set of A and B interval, so X is a real number that is in between A and B, but X does not equal to A or X does not equal to B. Similarly, we have closed intervals. So for the closed intervals, we use round brackets. In the number line, if we denote A and B, and let's say X belongs to A and B closed interval, that means all the real numbers in between A and B, and X can equal to A or X can equal to B. Any number in between A and B, including A or B. The semi-open or half-open interval, that can be A, B, or A, B. In this case, X can be B. In this case, X can be A. These two intervals, we call it semi-open intervals. And then we have the infinite intervals. Infinite. So infinite intervals can be written as A, comma, infinity. With the infinity, we always use the round bracket. With A, it can be either round bracket or square bracket. So this particular interval says X can be either equals to A or any number that is greater than A or equals to A. Or else we can say negative infinity to B. With B, it can be round bracket or square bracket. So this interval says any number less than B. So there are some intervals that we usually come across. One interval is called R plus. So this is all positive numbers. So if I show them as an interval, I can say 0 to infinity, and both are open brackets because 0 is usually not a positive number. And the other one you can say negative numbers. So this is all negative numbers. So if I show this as an interval, it would be negative infinity to 0. Both are open brackets or round brackets. Another one is all the real numbers but 0. So this is the union of negative infinity to 0 union 0 to positive infinity. Since 0 is not included, we can't use round brackets. We can't use that. When it comes to Cartesian plane or xy plane, x and y plane, or we call it XOY plane or Cartesian plane, we normally denote as r squared, and it is written as r squared equals x and y, where x belongs to r and y belongs to r. X and y are real numbers. Then we move on to the topic of relations. Before talking about the relations, we have to talk about ordered pairs. Ordered pair. So we normally write ordered pair as A and B. AB can be any element. In this case, we talk about real numbers, so we can say A comma B belongs to real numbers. So let's say there's another ordered pair which is C and D. In mathematics, we say ordered pair A, B equals to C and D only when A equals to C and B equals to D. In an ordered pair, A is called the first element and B is called the second element. Relation is actually a set of ordered pairs. For example, let's say there's a set. Set is and it has some ordered pairs. Let's say 1 5 is an ordered pair, comma 2 8, comma 3 5, comma 6 8. So S can be called a relation because S is a set that has few ordered pairs. If I take all the first elements of S and put it in one set, all the first elements, that is 1 2 3 and 6, and I put all the second elements in a separate set, 5 8, so this is called the domain, and this is called the range. This is actually called the codomain, but you can call it as range as well. So when I look at this relation, 1 is related to 5 and 2 is related to 8. 3 is related to 5 and 6 is related to 8. So this is the relation. So relations can be 1 to 1, 1 to 1, or 1 to many, or many to 1. Or many to many. One to one. Let's say this is your domain. Domain has elements 1 2 3, and it has a codomain or range. It has 5 4 and 3, and 1 is related to 5 and 2 is related to 3 and 3 is related to 1. 3 is related to 4, and this is called one to one relation, because for the elements for any element in the domain, there's only one element in the range. For example, 1 doesn't have more than one image in the range, 2 only has 1, 3 only has 1. The other one is 1 to many. For example, let's say there's another relation where the domain has 1, 3 and 9. In the codomain or the range, there are some other elements, 2, 3. So if let's say 1 has a image 2 as well as 3, and 3 has image of 2, and 9 has image of 2 as well as 3. So 1 is matched with 2 as well as 3. 3 is matched with 2, and 9 is matched with 2 and 3. So there's one element in the domain and there are more than one images in the codomain. So this is called one to many relationship or relation. So the next one is many to one. Let's say there's a domain. Domain has 2, 6 and 9. In the range we have 5, 7 and 11. So many to one, so in the, let's say 2 goes to 5, 6 goes to 5, 9 goes to 5. So many elements in domain is matched with one element in codomain or the range. So this is called many to one relationship. The other relation that can be found is combination of many to one and one to many. So 1 can go to 5, 1 can go to 9, 1 can go to 6, 1 to many. And 5 can go to 4, 5 can go to 3, 2 can go to 9. So it is a combination of 1 to many, many to 1, and many to 1 and 1 to many and 1 to 1. So this is called many to many. So these are the types of relations. So when it comes to a function, the first thing is it is a relation. That means it has ordered pairs. And the condition for a relation to become a function is no two elements in the domain in the range can have one element in the domain. So this is the domain, this is the range or the codomain. So the condition is there are two elements in the codomain or the range that cannot be matched to the same element in the domain. This cannot happen. So this is one to many. So one to many. This cannot happen. So if a relation has to become a function, it has to be either one to one relation or many to one relation. So these can become a function. Okay, let's make a kind of a table and see. Okay, relation function, yes, no. One to one, yes. One to many, no. Many to one, yes. Many to many, no. So this is the summary of the relations and whether they can become a function or not. So it has to be either one to one or many to one. So one way of finding out whether a relation is a function is to do the vertical line test. So in order to do the vertical line test, you have to first draw the graph of the function. For example, let's say y equals 2x plus 1. So if you draw the graph of the function, so this is x-axis, this is y-axis, so this is y equals 2x plus 1, and if you draw a vertical line parallel to y-axis like this, the graph should cut this vertical line only at one point. Then this is a function. So this is a function. Let's say you have y squared plus x squared equals 1. So if you draw the graph, so this is x, this is y, and the graph would be like this. So this is 1, minus 1, minus 1, 1, this is 0. And if I draw a vertical line parallel to y-axis, the graph cuts the vertical line cuts the graph at point 1 and point 2, so in 2 points. Therefore this is not a function, but this is a function. There's another terminology we use with functions. So let's say this is your domain and this is your codomain or the range, and in the domain you have x, in the codomain you have y. So x is called, this is the pre-image, and y is called the image. And there are some other notations that we use in the functions. So for example, if we want to say there's a function f, we say f, and if f is defined from real numbers to real numbers, we basically write f double dot r to r, and we can further say if x equals x squared. So x is a real number and x squared is another real number. In actual sense, we can say x is a real number and fx belongs to real number, positive real numbers including 0. Or else we can say there's a function f and it is defined from 0 to 4 close interval to r, and the function equation of the function fx equals 2x minus 1, etc. There's another thing we need to talk about, domain and codomain. So the codomain is the set that contains all the elements of the function fx. But if it is range, it can contain more than the codomain or the images.